In this question statement of the process heat transfer, consider a house with a floor space of 200 meter square, and this is the area of the floor space, and the average height of 3 meter at the sea level. So this is the height of the average height of the house. So where the standard atmospheric pressure is 101.3 kilopascal. Initially the house is at a uniform temperature of 10 degrees centigrade. So after some time we turn on the electric heater, and the heater runs until the air temperature in the house increases to an average value of 22 degrees centigrade. So it means that the purpose of the electric heater is to increase the temperature inside the house from 10 degrees centigrade to 22 degrees centigrade. So the first question is, determine how much heat is being absorbed by the air, assuming some air escapes through the cracks as the heated air in the house expands at constant pressure. So the second thing is, determine the cost of the heat if the unit cost of the electricity in that particular area is $0.075 per kilowatt hour. Let us just try to understand this question statement with the help of the diagram, and then we will try to solve this problem. So this is the diagram, and this is a particular house which has the air initially at the temperature of 10 degrees centigrade, and if we turn on the heater inside the house, it will increase the temperature of the air inside the house from 10 degrees centigrade to 22 degrees centigrade. So the first thing is that determine the amount of heat which is basically absorbed in order to increase the temperature from 10 to 22 degrees centigrade, and the dimensions of the house are also given in the question statement, that the floor area is 200 meter square and the average height is 3 meter, right? And the second thing is, you have to determine the cost of electricity that is being used to increase the temperature from 10 degrees centigrade to 22 degrees centigrade. So in order to solve this problem, first we'll take some assumptions that the air as an ideal gas with a constant specific heats at room temperature. So the second assumption that we are going to take is the volume occupied by the furniture and the other belongings are negligible. Obviously there are some furnitures and other things present in the house. So at this stage we are neglecting all the solid things which are present inside the house. So the pressure in the house remains constant at all the times. If the pressure remains constant, it means that the specific heat of the air inside the house will also remains constant. So the fourth assumption is the heat loss from the house to the outdoor is negligible during the heating process. So in the question statement the one thing is which is given is a small amount of heat is being lost from the cracks of the house. So in the assumption we are considering that the heat loss from the house during the heating process is negligible. So the air leaks out at 22 degrees centigrade. So if there may be some leakage of the house, so we are considering that it may leak after attaining the temperature at 22 degrees centigrade. So the properties that we are going to use in this problem in order to solve this problem, that the particular property is the specific heat of the air at the room temperature, and which is the Cp, the heat capacity at constant pressure. And because we are considering the constant pressure of the air inside the house, and it can be taken from the A15 table of the book which is basically provided to you, and the specific heat value is 1.007 kilojoule per kg per degree centigrade. So the first thing is you have to determine the volume of the house and the volume of the air inside the house. So the volume can easily be calculated with the given values in the question statement, that the floor space multiplied by height, and this floor space is the area, and if you multiply it with the height, we will have the unit of volume. So the floor space is given, that is 200 meters square, and thus the height of the house is 3 meter. If we multiply it, we will get the volume of the air inside the house, which is 600 meter cube. The second thing is we have to determine the mass of the air which is present inside the house, and it can be calculated by using this formula. And this is the very simplest formula that you had been used in your second year chemistry, that the mass is equal to the pressure multiplied by the volume over the ideal gas constant multiplied by the temperature. So the temperature initially in the house is 10 degrees centigrade. You have to convert this centigrade into Kelvin by adding 273, and the units of R, it is a constant, and it can be taken from anywhere in the literature. So its value is 0.287 kilopascal meter cube per kg per Kelvin, and the pressure is given in the question statement, that is 101.3 kilopascal, and the volume you just have calculated in the previous slide. After putting all the values in this formula and simplifying that, you will get the mass of the air in the house, which will be equal to 747.9 kilogram. So the one thing that we consider, the pressure in the house remains constant during the heating. So the amount of heat that must be transferred to the air in the house as it is heated from 10 to 22 degrees centigrade can be determined by using this formula, right? And this is the mass you just have calculated, that 747.9 kilogram. And the Cp is the heat capacity that you have taken the value from the literature, and the initial temperature, that is 10 degrees centigrade, and this is the final temperature, that is 22 degrees centigrade. And after putting all the values in this formula and after simplifying that, you will get the final value of the energy which is being absorbed by the air in order to raise the temperature from 10 degrees centigrade to 22 degrees centigrade. So 9038 kilojoule is the amount of heat which is basically absorbed during this temperature rise. So in the question statement it was given that, so the 1 kilowatt of the energy is equivalent to 3600 kilojoule, and this is the conversion factor, right? So you can easily memorize this conversion factor. The kilowatt hour can be converted into 3600 kilojoule. The cost of electrical energy at a unit cost of 0.075 per kilowatt hour is given in the question statement. So you have to use this formula in order to determine the energy cost. So this is some misprinting. So this is energy cost. The formula is the energy used that you have calculated in the previous slide, and the unit cost of energy. So in the previous slide you have determined this value 9038, and the units were kilojoule. When you convert this kilojoule unit into kilowatt per hour, you have to divide it by 3600. So the kilojoule unit can be converted into kilowatt per hour by dividing it with the 3600. So this parameter has overall unit of kilowatt hour, and if you multiply it with the unit cost of energy, that is 0.075 per kilowatt per hour, so per kilowatt hour and the kilowatt hour will be cancelled, so the overall answer will be $0.19. So $1 has 100 cents. So it can be further explained in this way, that it will cost the homeowner about 19 cents to raise the temperature in the house from 10 degrees centigrade to 22 degrees centigrade.